Educational GMAT. Your partner in your GMAT journey.
So that this is very clear to everyone. This is basically 10 raised to the power of 5 divided by 287 t plus 273. So y-axis is absolute humidity, while x-axis is temperature. Okay. So obviously there is if you look at it, a positive correlation between temperature and absolute humidity. So which means higher the temperature, more is the amount of water vapor that atmospheric air can hold. And this is shown for from 1 degree to 41 degrees. So when the air contains this maximum amount of water vapor, for example, at 17 degrees, if the air is containing this much amount of water vapor, the air is said to be at its saturation point. In addition, at sea level and at a temperature of T degrees, the density of air containing no water vapor. Mind you, this is maximum water vapor, while this formula gives you the density with no water vapor. So this is maximum water vapor, this is no water vapor. All right, at 37 degree, the weight of water vapor is dash percentage of the weight containing no water vapor. Very nice. So one is basically saturation point. How do we find out saturation point? Through the graph, right? Correct. Weight of water vapor is this, because this is no water vapor. So 37 degrees is, now we need to go a bit deeper. So with 37 degrees, how much is the water vapor? 40, around 40? Little more, right? 41 perhaps. Right, almost 41. Okay, let's take it as 41. So now here is another thing, guys. Yes. So what you need to notice is that absolute humidity is given in terms of gram per meter cube, while with no water vapor, it is kilogram per meter cube. So perhaps we can convert kilogram into gram. Correct? So now let's do that. So weight of water vapor we found out is how much? 41, right? Let's take this as 41, correct? While no water vapor, we obviously use this diagram in this particular formula. So 10 is the power of 5 divided by 287 into 37 plus 273. Mind you, this is what? Kilogram per meter cube. So now so you have the calculator at your disposal. Can you tell me the answer for this? 10 to the power 5 divided by 287 into 310. Am I correct? So how much does this turn out to be? Very nice. How much is this, by the way? So let me use the calculator. No, no, why around? Divided by 287 divided by 310. So it's giving me 1.123.
Yeah, it's
All
around
right.
112 in gram per molecule.
Very nice. It is kg per meter cube, which would be 1123 gram per meter cube. Correct? So it's basically just asking that this is what percentage of this. Correct? So essentially it's just 41 divided by 1123 into 100. Correct? So which would be, by the way, how much? 4100 divided by 1123, which is 3.65. And so that's the answer. So yeah. So using calculator is definitely time consuming, but I will be very honest with you. Frankly, I'm not at least confident about my capability of. I'm not comfortable. I'm sorry, I'm not comfortable. Especially that, these values are not like very far. So I would definitely not trust my computational abilities. I would use a calculator here. I'm with you on that. I'm with you on that. Yes, I'm with you on that. That, this is perhaps almost 10 lesser than 300. This is 10 greater than 300. So let's take it 300 into 300. I'm fine. But I mean, exercise caution. So I am very clear on that. If your question is that can this kind of a question be asked in quant where calculator is not allowed? So my answer would be no. Quant questions where calculator is not allowed definitely don't test you on these kind of calculations. All right. Yeah. Between 31 and 41. So by the way, it's just talking about the graph here. Correct? Now, rate of change. What does this remind you of? Slope. Rate of change is always slope. So rate of change of maximum humidity between 31 and 41 and then 11 and 21. Okay, all right. Between 11 and 41, 31 and 41. So this between 31 and 41, correct? So we are talking about this area. And then 11 to 21 is obviously, so this is 11, this is 21, correct? So we are talking about this area. Sorry? Oh, we have to tell us visually, by the way. Yes, absolutely. So basically, it's saying that the slope, is it greater for this area or is it greater for this area? Correct? And I think this is where what we discussed earlier would come into picture. Visually, we need to essentially figure out, if you look at it, the slope, right? Is it steeper in area 1 or area 2? Clearly, area 2 is steeper, right? If you look at it, it's like this, while area 1 is much more horizontal than area 2. So clearly, the slope is more where? In area 2. Agreed? And hence, Notice area 2 is between 31 and 41. The slope is more than the slope is between 11 and 21. If it had been on average, this rate of change is rate of change. Like y2 minus y1 by 2. Yeah, I would agree. So the question that Siddharth had was, what if there was no average here? Rate of change. So rate of change in that case, let's say between 31 and 41. So 31 was basically this, 41 would be this, correct? So the rate of change would have been basically the final value minus the initial value divided by, in this case, 10. That would give you the rate of change.